All right, hello. Today we're gonna be doing some calculus. So, gonna make sure that we are doing, you know, a lot of homeworks because I have my exam in a little bit under 2 hours. So I wanna touch upon uh, some of the homeworks that I have to do. Again, I have my formula sheet, and I'm just going to review some of these problems because, yes, I've done them, but I do want to make sure that I am perfectly prepared for solving some of these problems. So, let me go back to my 5.2, and I also decided to change my, little bit off topic, but I decided to change my dieting goals. So starting today, I'm finished with my cutting. I went from 175 to 140, so I'm 140 right now. But I'm going to go from 140 to 180, something like that. So I'm gonna continuously, slowly build that muscle up, and then cut that fat, and then build that muscle up, cut the fat, build the muscle up, cut the fat, and just slowly build myself up. So I've been doing that for a year now. So this is my first year where I've built the muscle and then cut. So starting today will be my second year essentially. So with that out of the way, let's do the calculus, which Calc 2. Okay, so we are on problem 19. So the problem 19 is the integral of x to the power of 3 minus 3x to the power of 2 plus 5 divided by x minus 3. So this is another problem where you have to utilize long division. So I'm gonna do that really quickly. So x minus 3 is going to be on the outside. X to the power of 3 minus 3x squared plus 5 is going to be on the inside. So dividing, you would need an x squared, so you multiply it by x squared, so then this gives an x3. Negative 3 times x squared is going to be negative 3x squared. So if you subtract that, it's going to subtract this, and it's also going to subtract that. So that cancels out, and then we're left with a 5, a very simple 5. So the answer should be x squared plus 5 over x minus 3. And then we still need to find the integral of this. So the integral is going to be actually, the integral of this is going to be x to the power of 3 over 3 plus, and then this turns into 5 multiplied by x minus 3 to the power of negative 1. But actually, what am I doing? You don't need to do that because you can actually utilize the ln rule. So you say you put 5 on the outside, ln of x minus 3 plus c. That should be the answer. I have my wonderful notes just to make sure that I'm doing this correctly. So 19 should be x to the power of 3 plus 5. Perfect. Alright, so I think I have the long division integrations out of the way. I don't need to worry about those. The integration of, okay, I'm going to do number 25. 25 looks interesting. So 25 is 1 over square root of x multiplied by 1 minus 3 square root of x dx. So from what I understand, it looks like we can try to set u is equal to possibly 1 minus 3 square root of x, and then du is equal to the integral of that, or the derivative of that, which is going to be or maybe, because we're trying to find the indefinite integral, what we could instead try to do is We could try to set it up as like a ln form. So instead of using u substitution, what we could do is we could do like ln of 1 minus ln of I think minus 1/2 ln of x plus ln of 1 minus 3 squared root of x. I think that's possible. Let me check actually. Nah, that's not possible. Yeah, I was okay. I didn't want to do the u substitution for this one because I was like, it's a little bit long. Don't really feel like doing that. But apparently the du is going to turn out. So in order to find the du, we need to take the root out. So 3 square root of x is simply going to equal 3 multiplied by x to the 1/2. Right, so then the derivative of that, which is going to be 3x to the negative 1/2 over 2, which means that this is going to be 3x, actually it's going to be 3 over x minus 2. Or maybe it's 3 over 2 plus x, 2 plus x to the 1/2. Yes, that should be correct. Yep. And that should be a negative. So then this is going to go back into the integral. So going back into the integral, it will turn out to be 1 over square root of x, and then this is going to be u, and then it's going to be du over the new integral, which is, if you're going to flip that, it would be du 2 plus x to the 1/2, and then over 3, or actually over negative 3. So if that's the case, it cancels out, so the square root of x cancels out, and then you can take out the negative 2/3, which leaves it to be 1 over u. So that's pretty nice. Du. So then it's going to be negative 2/3 ln of u, and in this case u is 1 minus 3 square root of x plus c. It works. Nice. Okay, just need a little bit of refreshers. So not bad. Alright, moving on to 5.3. 5.3 is going to be inverse functions. So inverse functions is simply, from what I understand, reversing the two different formulas, or the two different, so like for instance, if you're solving for x, you switch that and then you solve for y instead. So that's hence the name inverse. So if we look at our formula sheet, it states that 5.3, we're going to be doing problems 17 to 21 and 45 and 49. So let's do a couple of those. 17 to 21. Okay. So I'm going to write it right here. 5.3 review, which is going to be 17. So 17 is the h of s is equal to 1 over s minus 2 minus 3. 1 over 2, or 1 over s minus 2 minus 3. So that's going to be the h of s, right? We need to set that equal, because that's y equals, I believe. Y equals s minus 2. But then, we need to set that so that it's s equals 1 over y minus 2 minus 3, right? So what we need to do is so we need to add 3 on one side, so it'll be s plus 3 is equal to 1 over y minus 2. That's weird. And then you multiply y minus 2 so that you can put it on the other side. So it'll be s plus 3, multiply that by y minus 2. think you have to multiply, so you have to distribute. So it'll be sy negative 2s plus 3y minus 6 is equal to 1. So then you group these things. I'm a little bit confused on this one too. Okay, let me see. I would like to see what they did. What is this? So they okay, so this is me redoing my stuff. 5.3 homework, let's see. So 17. What? Use the horizontal. Oh. Okay. Okay. I don't think I need to worry about this. I need to look at the prompt before I actually try to solve it, because it doesn't even say to solve the equation. It just says to use the horizontal line test. So yes, it's gonna pass the horizontal, and it is 1-to-1. Right? It is 1-to-1. And then 45. Okay, so 45 and 49. Because the horizontal line test determines if the function has two points that are, like, you know, when you do the horizontal line test, if you go horizontally, if it hits 2 points in the graph, then it fails the horizontal line test. But it doesn't in this case. And what does it mean for it to be 1-to-1? That's my question. Okay, so it appears that the f is increasing over its entire domain. To verify this, note that this is a positive on the domain. You're giving a function that is not 1-to-1 on its domain. By testing whether a function is 1-to-1. So show that the sine function is not 1-to-1 and a real number. Okay, so it is clear that the function is not 1-to-1 because of the many different x values. Same okay. So it essentially states that if there are multiple points during the x-axis, it is not 1-to-1. However, it is 1-to-1 in a specific. It is 1-to-1 if there are only, you know, specific, like, points in the x-axis. If they continuously go up and down and up, just like a sine x, then it is not 1-to-1. Okay, 5.3 is not too bad. Let me do some of the problems for 5.3, because I do want to make sure that, like, you know, I'm doing this correctly. So if we go to 45, I think 45 is potentially something that could be on the exam. 45, so I'm gonna skip these other ones because I don't need to, right? I highly doubt it's gonna be on the exam, especially an exam that's only gonna be 15 minutes. So 45 could be one of them, which is f of x is equal to the square root of 4 minus x squared from 0 to x and to 2. Perfect. So how do we solve this? We know that y is set to, you know, the function, but now we just need to switch it. So now we switch it so that it is x is equal to square root of 4 minus y squared. And now we flip everything to the other side. So we square this, we square that, so then it'll be x squared is equal to 4 minus y squared. Subtract 4, x squared minus 4 is equal to negative y squared. And then so then we can flip the signs too. So it'll be y squared is equal to um, negative x squared plus 4, and then we can square root this. So then the entire function will be y is equal to the square root of negative x squared plus 4, or in this case it would be 4 minus x squared. Yeah. And there we go. So that's just simply flipping from one to the other. And then if we go to like another problem like 47, we'll do it anyways because, you know, why not? It's a fairly simple problem. So the f of x is equal to 3 square root of x minus 1. Set that so that it's going to be the inverse, so then it's going to be y minus 1. So then now we need to do the 3 square root of 2, right? So then it's going to be 3 over 2. Three square root of 2. So I think because if we do it to the power of 2, then that's not really makes sense. Okay, this one is a little bit interesting. And like if you find out, oh, the domain and ranges. So right. You can also find the domain and ranges. Like going back to problem 45, if you use the original function, you can find that the domain is going to be domain is the x-axis, I believe. So it's going to be from 0 to 2. Range is going to be the y-axis. And then you can flip that over the inverses, which is going to be the same thing. So yeah, that makes sense. So then that's 45. Where's 47? I know I did 47 here somewhere. Oh, we're not supposed to do 47. Okay. So that's not going to be in the problem. Not going to be in the exam, which is very nice. Very nice for us. Let's do 49 then. 49, f of x is equal to x over square root of x squared plus 7. So, in order for us to solve something like this, same thing. We set that equal to x, so it's going to be y is equal to square root of y squared plus 7. So we multiply this by the same thing, square root of y squared plus 7. So then it's going to be x times y squared plus 7 is equal to y. So once we have that, I believe we can square these. So we square every single thing, which would make it x squared, multiply that by y squared plus 7 is equal to y squared. Now, if we cannot necessarily do something like that. So what we can do is we can distribute this, so it's going to be x squared, y squared, and then x squared, y squared, and then plus x squared plus 7, I think, right? Or 7x squared. And then I think what we could do is subtract the 7, or Let me see what they did, or what I did in the past. Okay, I did that. Okay, I did that as well. Okay, I also did that. So you subtracted. Oh, okay. Whoopsies. Okay, so then we get 7x squared is equal to y squared minus x squared y squared. We distribute the y squared, and then we are left with 1 minus x squared is equal to 7x squared. And then we're going to divide, so then it'll be 7x squared over 1 minus x squared. And then do the square root. So then the final answer is going to be the square root of 7x squared over 1 minus x squared. Plus minus. Perfect. Okay. That's the correct solution. And just like that, we should be good to go. Going to exponential functions, differentiation, and integrations. Okay, let's do that. So 5.4 review. This is good. So it's 12:30 right now. We have another hour, a little bit more than an hour. So I think I'm going at pace, which is good. 5.4 is from 91 to 117, right? No, okay, so the starting is 33 to 55, or 53. So find the derivative of the function. So, okay, so, let's do number 33 real quick. So y is equal to e to the 5x. So going back to our formula sheet, from what I understand, I believe we just take the 5 out and then we multiply it by itself. So if we look at the 5.4 problem, just to make sure, because you wanna, gotta be careful. Yeah, so that's, they have the, I wrote down the same thing. So y prime is simply gonna be 5e to the 5x. 35 is going to be y is equal to e to the square root of x. So we know that square root of x is equal to x to the 1/2. So what we could do is, I think what we could just do is like y prime is equal to 1/2 e to the square root of x. I'm pretty sure. I just did it again. Yeah, 5.4, there we go. Okay. So it seems to me like I did it incorrectly, because I'm supposed to be doing the chain rule, apparently. So, what? I don't know if this is correct, the one that I did. I guess it is, since, okay, so e to the square root of x, multiply that by e to the, so it's gonna be x to the 1/2, correct? So you start off with x to the 1/2, so then you put 1/2 on the outside, and then you go to the negative 1/2, then you multiply them. Yeah, so then that should just be the answer. E to the square root of x multiplied by the derivative of the top. Okay. Yeah, that makes sense. So when you're doing these differentiations, you're just simply doing the derivative of the top times, yeah, so it's going to be e to the, okay, this is a little bit unclear. It should be e to the u times u prime. There we go, that makes a lot more sense. Yeah. So that's going to be 35. 37 is y is equal to e to the x minus 4. Well, the y prime is going to be the same thing, e to the x minus 4. Multiply that by the derivative of x, which is 1. So it's just going to be the same thing. 39 is y is equal to e to the x ln of x, which in this case would be the product rule. So first times the derivative of the second, which is 1 over x, times the second, which is ln of x, times the derivative of the first, which is e to the x. So this should be the answer, because e to the x derivative is just itself. 41. 41 is y is equal to x plus 1 to the power 2 e to the x. So whenever I'm doing these problems, it's a little bit more interesting. Y is equal to x to, okay, so we're doing, yeah, this is another product rule basically. So this is gonna be the last one and then move on to the other one, because I realize that I have a lot more difficult integrations that I need to do, or just longer simply. And I want to make sure that I'm correcting those. So going back to this, it's gonna be 2 times x plus 1, 2 times x plus 1, do the first, okay. Times e to the x plus the original, which is x plus 1 to the power 2, times e to the x. Right? That was very weird. Yeah, it is just that. Okay, that's not too bad. Let's move on to 91. So going to 91. Where's 91? Oh, it's a little bit down here. Find the indefinite integral. Okay. So going to 91, the integral is e to the 5x multiplied by 5 dx, right? So in this case, I believe you just need to do a simple u substitution. Usually the power is the u. So the integration is going to be, so you cancel the 5 out, so it's going to be e to the power of u du. And then I'm pretty sure e to the power of u is 5.4, right? 5.4 only has the derivative. I need to, so 5.4, the integral is going to be, crap, what is the integral? If it's e to the power of u, the integral should be just u, I think, right? I'm a little bit confused. Okay. It's a lot simpler than I thought. Man, okay, it's really good that I'm going over these things, because like, I did every single one of these homeworks, but then I still forgot, which is crazy. So e to the 5x plus c. I want to see like what the thought process is. So that's 5.4. Oh, right here. Let's, okay, so this is, so the integral of e to the x dx is simply going to be e to the x plus c, and the rule is that the integral of e to the u du is going to be the e to the u plus c. Okay. E to the u is equal to is equal to e to the u plus c. Hey, perfect. Okay, so that's fairly simple. So if that's the case, you just kind of keep the thing. You just kind of no. You did need to you did have to use u substitution for that. I guess I just simplified that one. Okay, I don't know why I did that. Anyways, maybe it was so easy back then. 93 is e to the 5x minus 3 dx. So yeah, we just need to use substitution, I believe. Oh, actually, wait, what the fudge cakes? What the fudge cakes? Yeah. So u is equal to 5x minus 3, du is equal to 5x, or actually it's just going to be 5. So now that we have this, du is going to 5x dx. It's going to be the integration of e to the u, and then du over 5 multiplied, which means that we can take the 5 out, so it'll be 1 5 e to the u, which is e to the 5x minus 3 plus c. Yay! Nice. Okay, so then 95 is going to be the integral of 2x plus 1 times e to the x squared plus x. And this makes it very obvious because now I can immediately tell that, x squared plus x is going to be the numerator, or the u, and then du is going to be 2x plus 1 dx, which means that it's going to cancel out. So that should be canceled out. So then we're going to be left with e to the power of u du, which the integral of this, oh no, that is the integral. Oh no, that's okay. So then we're going to be left with e to the power of u, which in this case is e to the power of x squared plus x plus c. That should be answer. Yeah, e to the power of x. Okay, I understand. I'm going to do the last questions. Usually the last ones are the hardest. So I'm going to do 117, right? So 117, here I come. I'm going to do it on the, I'll just do one side. Okay, so 117 is, this is a definite integral. So the integral from 0 to pi over 2 e to the sine pi x cosine of pi x dx. So u substitution, so u is going to be, u probably should be sine pi x, because du is going to be cosine of pi x dx. And then the integration is simply going to be from pi over 2 to 0 e to the u du, which means that it's going to be e to the u du, so from pi over 2 to 0, so it's going to be e to the power of sine pi x from pi over 2 to 0. So it's just going to be e to the sine of pi over 2, right? Oh, no. E to the power of 2 pi over 2, but then the 2 is going to cancel, so it's just going to be e to the sine pi. I think that's the correct answer. Let me see. E to the u, right? E to the sine pi. Oh, yeah. And then it's going to be minus e to the because if you put 0 in there, right? E to the sine of pi. Okay, so I think that's how you would probably say. Yeah, okay, that makes sense. Not bad. Okay, so moving on to 5.5. So 5.5 is going to be bases other than E. So then 5.5 review. Okay, so 5.5 review states that's going to be the bases other than E. So we have some couple of functions that we have regarding 5.5. Actually, a lot. Oh, whoa. Okay, 5.5 has a lot. So let's go to some of the problems. Okay, so 5.5 is this. Okay, so it's gonna be these ones. Got it. A prime of U. Okay, so 5.5 problems 39 to 59, 69 to 79. Okay, let's start with 39. So find the derivative of f of x is equal to 4 to the power of x, right? So according to our rule, going to 5.5, if it's going to be a to the x, then it's just simply going to be a to the x ln of a. So if it's 4 to the x, it's going to be 4 to the x ln of 4, correct? Yay, okay, perfect. So then going by the same rule, we know that if it's going to be y is equal to 5 to the negative 4x, I guess it's just going to be 5 to the negative 4x ln of 5, right? Okay, and then you have to do the derivative. If there's a coefficient, there, you need to do the derivative of that and then multiply. Okay, a little bit more, but that's fine. So in this case, it would be, we do the derivative of the top, which is going to be negative 4, and then ln of 5 multiplied by ln of 5. Not bad. 43 is going to be the f of x is equal to x. Okay, that looks kind of weird. So it's going to be x times 9 to the power of x. So we got to use product rule. So first, which is going to be 1 times 9 to the power of x, plus the derivative of 9 to the power of x, which is simply 9 to the x ln of 9 times x. Is that correct? 43. Yep. Perfect. And then 45 is going to be 45 is f of t is equal to negative 2t to the power of 2 over 8 to the power of 2. Now, if I look back at my 5.5 rules, okay. If I look back at my problems, I think the way I would solve this is, I guess I could just use the quotient rule, right? So it would just be y prime is equal to low. So the derivative of the okay, no, it would be 8 to the power of t times the derivative of the top, which is going to be, what? Negative 2 to the t squared. So I guess it would just be negative 4t plus, or actually minus, it's a quotient rule, minus the top, low d high, high d low. So then minus negative 2t squared. Well, actually, technically it turned out to be plus. And then multiply that by the derivative of the bottom, which is 8 to the power of t ln of 8 over 8 to the power of t squared, which is simply 8 to the 2t, I believe. Now let's see if this is correct. I'm curious to see if I did 45 correctly. Hey, let's go. I did it correctly. Alright, so I do understand some of the fundamentals. So 5.5 is from 39 to 59 and 69 to 79. So let me do some of the 69 and 79s. So then this is going to be the integral section. So 69, someone outside. 69 is the integral of 3 to the x dx. So is 69 going to be the same rule? Let's find out. Okay, 5.5. So the integral of a to the x, which is, yep, a to the x dx is equal to simply the a to the x on the top over the ln of a. Okay, so this is just going to be 3 to the x over ln of 3. And then 71 is going to be the integral of x squared plus 2 to the negative x dx. Okay. I think you need to use this u substitution for this one. That's what it looks like to me. It looks like you need to use the u substitution. So if I were to use the u substitution, I would, I guess, use negative x. Okay, let me just check. I don't have much time, so let me just see what I am doing. Bro. Okay, never mind. I forgot. I keep forgetting. It looks complex, right? It looks complex because it's like, oh, x to the power of 2 plus 2 to the negative x and then dx, right? But you have to go back to your fundamentals. It is simply telling us to do the integration. So the integration of x to the power of 2 is simply x to the power of 3 over 3. We know that already. And now we do 2 to the negative x. So 2 to the negative x is going to be on the numerator over the ln of 2. Is that correct? Plus c. That is way simpler. Way simpler. Okay. So I think one good thing to realize is that, like, if I'm on the exam and I take more than like a minute to question myself, I'm like, wait a second, how do I do this? Then I'm probably doing it incorrectly or not thinking the right way. But this is way easier. X times 5 minus x to the negative 2 dx. Okay, now this is a little bit different because now you're multiplying, you're not adding. So you can't necessarily like do the integration right away, right? Maybe you can. Apparently you can. What? That is weird. I did not know you could do that. Okay, I need to verify if 73 is correct because the way I did that was separating the integrals. Chapter 5.5, right? Number 73. -1 over. Is that the same thing? I think that's the same thing. Okay. What? That's so weird. X plus the integral of 5 minus x to the -2. So then that would just be x to the power 2 over 2 plus 5 minus x to the power -2 over ln of 5. No, that's not correct either. The way I saw that wasn't even correct because oh. Whoa, I copied the question incorrectly. So it's 5 to the negative 5 to the negative x to the power 2. So then yes, ln would be 5. Let me just question. Let me see. In an integration, if two are multiplying each other, can you can't speak. Okay. So it would be multiplying. So x to the power 2 over 2 multiplies. So it is, so you can separate them, but it just needs to be a multiplication symbol. Makes sense. So that's not too bad. Yeah, that's really not too bad. So let's go over to, oh god, okay, my stomach is crying for help. So I'm gonna use the bathroom really quickly. And yeah. Okay. Let me see if I can do a pause feature. If I can't, then I might just have to end the video here. Yeah, I don't think I can do that, so I hope you guys enjoyed this video. It's a little bit short. I was gonna do another hour of this, but my stomach is really hurting, so I'm gonna have to call it a day. So see you guys later. Peace.